Hello class, in this video we're going to talk about our homework problem 1, contract bidding for government project. So I will first describe the problem very briefly, and then we'll talk about how to solve the problem with a risk, and then we'll see the result. So first thing first, Miller's Construction is trying to bid for government construction project. The cost for this company to prepare a bid is $350, and the cost to complete the project is this amount. So this is a very competitive, it's not a very competitive market, but there are few potential bidders, and the number of competitors fall in the market, but they will not all going to bid for this project, and there is some chance you have say 2 competitors. The corresponding probability is this. Sometimes the 4 competitors would all join in a project for bidding the contract, and the corresponding chance is this. So obviously it's for the number of competitors following a discrete distribution here. So suppose competitors 1, suppose it decide to join to bid, then the bidding amount is the cost for Miller's Construction to finish the project multiplied by a normal multiplier. The mean of this the normal distribution is 1.5, a standard deviation of 0.3. So sometime they will bid over this cost, sometime they will bid lower than this cost. And the problem is to decide what's the optimal bidding amount for Miller's Construction. If they bid too high, if they win the project, that would be great. They can earn this amount as their revenue, but there will be very low chance they can win with a high bid. On the other hand, if you bid too low, then they are very likely to get a project, but they will only earn a low profit from this project because they just offer such a low price. Okay, so that's the trade-off. Now let's start to look at this problem, how to solve this. Our first thing is to load our risk in our computer. Let's see. Oops, not this one. So I have a risk. I think I downloaded risk. It's a free trial version, risk 7.5. So while I'm loading this, I'm just basically briefly talk about the idea behind the simulation. You first generate the number of competitors as a random variable, and then you it seems I have some technical issues here. Okay, now I'm done. Good. So the first thing we're going to do is to generate the number of competitors which follow in this distribution. Then suppose the number of competitors. So let's first do that first. So it's following a discrete distribution number of competitors. As you see here is 2 sets of parameters. First is the number of possible value of competitors, which is from E5 to E5. What is happening here? E5 to E line. That's the possible number of competitors, and their corresponding chance of taking this value is from F5 to F line. It'll give you a quick preview of the distribution. It looks like this. Press OK. Every time you hit F line, you should be able to see different realization of the number of competitors. So in this case, there are 2 competitors, which means the first 2 competitors would place a bid. And to do that, let's first write down the number of bid, the amount of bid they would place for the first 2. So let's define the distribution. We know the amount that they were going to bid is a normal distribution multiplied by the cost. So the normal distribution is with mean 1.5, which is E11, and standard deviation is B12. This is the multiplier, and we multiply by the cost, which is 5. So this is the amount they would place. The competitors would bid, which is the cost of Miller's construction to finish a project multiplied by a normal distributed multiplier. And let's first log these few cells, so we can when we copy these cells, it doesn't change. However, note that we would only the first two competitors would actually place a bid, because the number of competitors is 2. So in order to do that, we have to write an if function that basically says the first two competitors, that is less equal to total number of competitors, then these competitors would place a bid. Otherwise, they would not. So then return nothing. So that's not finished yet, because we want to drag this formula in the next 4 cells here. So in order to do that, we have to carefully place $sign in front of these numbers. So this number of competitors, so we don't want it to change when we drag this. So let's first log this cell, B18 cells. But for this cell, since we're going to drag this, for example, when we drag this to this cell, which is corresponding to 80, we want this C 17 to be D17. So that means we're going to allow C to change and log number 18 here. So that's the formula. That's the final formula we would have. And then we can drag this into different cells, and we press line, see different realization. So in this case, two competitors. So the first two competitors would place bid, and the next two would not. If it's only one competitors, then the first one would place a bid. Okay. So the next one is to calculate the minimum bid, which is the minimum of these 4. And Miller's construction only win a bid if the bidding amount is less than the minimum bid. Then Miller's construction would win, and with 1 to represent win and 0 represent lose. And correspondingly, we can calculate profit. So if they win, then the profit. If they win, then the profit is this amount. This is the bidding amount, which is the profit they would earn, minus the construction costs, minus the cost to prepare the bid. If they doesn't win, they have to pay the bidding cost. So this is the profit. And these are the two variables we are interested to measure: the chance they would win and the profit they would earn. So we're going to define this as our output. So add 2 output here. Since we have, let's say, 10 different numbers of evaluation, so we're going to change the simulation number to 10. And in order to evaluate these 10 numbers, we can't use a fixed number here is the Miller's bid. We have to tell the program these are the number of bid, these are the bidding amount we want to evaluate. To do that, we're going to use a function called risk semi-table and choose this potential bid here. So that's telling the program these are the potential bid amount we're going to evaluate. Now we change the simulation to 10. We would evaluate these 10 numbers for the illustrative purpose. We're going to set simulation number of iteration to 100 to short our time, and then we can start simulation. This might take a while, and while I'm doing this, I'm just going to say, it's actually really quick. So you can see this is a result. You can see different number of simulations here, and you can also switch between 2 outcomes. By click here, you can see this is the outcome of winning probability, and this is the outcome of the profit. and you can look at different number of different simulation type here. So as you see here for simulation 2, which corresponded to bidding amount of 11,000, the mean profit is 401, 410, and standard deviation is 429. And to get an overview of the result, you can see summary here. So you can see the summary, which says, okay, for the winning probability for different simulation numbers, this is the mean winning probability, and also you can look at their profit. You can also export the result into Excel. So let's click this. Oh, it seems we have the same problem again. You would not have this problem because I installed this free trial version on my PC just to record for the purpose of record this video. But in the computer lab, we will not have this issue. Oh, it seems I have to click OK here. So we are going to see the output the result in Excel. And we're going to we will check this output result summary here. Let's press OK. Let's just click No here. It takes a moment. Okay, so this is the same thing we just look at. As you see here, for different simulation number from 1 to 10, this is the average winning probability, the mean winning probability. And we're going to copy here. So it's probability of winning. Oops. Copy the cell as winning probability here. And next we'll copy this profit from simulation 1 to simulation 10. Copy the profit. So this is the mean profit we're going to copy. That is the average profit. The average profit. Here is the profit. So as you see here, if you place a higher bid, the profit first increase, and all the way to this one is around roughly when the bid is between 7,000 and 7,500, the profit is reaching its maximum. In this case, this profit and these two bids are equally attractive because they have same expected profit. If you increase the bid further, then you will actually decrease your profit. Notice that the winning probability will always decrease when you increase your bidding amount, because if you place a higher bid, then you would have a lower chance that is lower than your competitor's bid, so you would decrease your chance of getting this project. But for the purpose of this problem, we're going to say choose these are the two optimal bids you could take to maximize your expected profit. Thanks for watching. That's all for this problem.